It's a pleasure to be here and speak to you all. How's that looking for everybody? Good? All right.
Very good, not good, very good.
And I haven't even started yet. Okay, so yes, it's a pleasure to speak to you all. I'm really looking forward to coming to India. I've never been, and I'm very excited about the opportunity. Yes, I'm going to be speaking about systems empowering humans to manage better information, and the order of those words is important. Of course, the long goal is to empower humans to do better work, to manage information better. But the thesis of this talk is that we have to improve the quality of the information that humans are managing if we want them to be able to do a better job. And I always like to start with the conclusion in case people have to leave early or get distracted. And so the conclusion that I hope you'll take away with this talk is that people are actually really good at managing information. When you have somebody who has a particular job, they develop a lot of expertise and they gain a lot of knowledge and understanding of the information that they have to work with and what are the best ways to organize and visualize that information and explain it to other people. But unfortunately, a lot of the tools that we give them make them dumb. They interfere with people's ability to manage that information the way that they want to express the knowledge that they've gained over time, and to organize the information effectively according to their own needs. And this is a real problem because if the tools won't let people put in the information that they understand, then you can't recreate that information from through computation. It just isn't there. So instead, we need to improve the interfaces that people use to convey information to the computer and the models of information that the computer has, so that people can actually provide the intelligence. I know I'm coming to this artificial intelligence institute, but I'm sort of taking this contrarian view that you can't forget the role of the human. And that's what I'm going to be focusing on. And I'm going to be looking at some ways to make things better. Both looking at ways to let end users create their own perfect applications for the tasks that they want to do, and also tools for improving the structure of large online discussions to make them more useful. So my group in general focuses on one really big question, which is how we make it easier for regular people to manage information. And there's many different aspects of that management. You need to capture the information, organize it. Whoops, I don't know why my slides are advancing themselves. You need to capture that information. You need to organize it, retrieve it, share it with other people, talk about it, annotate it, and so forth. And so we're interested in all of these aspects of the work. The methodology that we use is centered in human-computer interaction. And this means, but we actually do draw from a very large number of domains, including information retrieval, databases, social networking and social science, and many others. And our research tends to follow a cycle where we will actually study users in order to understand their needs. We'll then build systems that we hope will meet those needs, and we'll then deploy those systems to users, either in the laboratory or in the wild, in order to, and then study what they do with these new systems in order to validate our ideas and prove that we've done them correctly. And of course, from those deployments, we learn new things which take us back to the beginning of the cycle, so that we can make another generation of tools. So just to sort of drive this point home, I think when you look at current systems, what you often see is a human being sitting in front of the computer, and the human has a very good picture in their mind of this information that they need to work with. And then they work through this very, very narrow interface, which barely lets them convey any of their understanding of the information to the computer. And then we throw a tremendous amount of computation at this little bit of information. And the computer tries to imagine what it is that the human was thinking about, but can't do a very good job because just not enough information was delivered to the computer. And so I want to fix that. Now, what do I mean about the delivery of information to the computer? Well, I want to talk about structure. So I want you to imagine that you go to YouTube and it's a text-only website. So you sign in and it tells you in text that you have a collection of videos called favorites, and the first video in the collection is a video of a flock of birds by a certain videographer, and it's 17 minutes long, and your second video is this. And then you would tell the computer, to play the seventh video, or to move the fifth video to the top, or to move it into a different collection. This would be a rather difficult way for you to interact with that information. And fortunately, the YouTube website is not a text website. It is a website with a lot of structure in it. You can see at a glance that you've got this collection of videos, that they're ordered in a list. You can see what the first one is. You can see at a glance how long each video is. You can drag things around and use menus to move them from place to place. So the structure of this information, the fact that it is a collection of videos, they each have durations, they each have videographers, there are these different collections that you can manage. It's all visible at a glance, thanks to the underlying structure of the information. So this structure gives you a regular arrangement of the data that you're working with according to properties that you know. And it can also specify for certain properties a fixed set of meaningful values. And it can lay out the information so that you can perceive it at a glance. And it can give you special widgets, buttons, and menus and things in order to manipulate that information. And it also will allow you to sort and filter this information according to particular properties, right? On YouTube, you can say, I only want to see the videos that are between 5 and 10 minutes long. And it can also let you aggregate the information in computational ways. If you have an entire playlist of videos, because you have these numerical durations, you can add them up and report what is the entire duration of the playlist. So there's a lot of benefits to this structure. And this is why we have all of these specialized applications, our mail clients and our address books and our music players and our photo albums. These are all tools that materialize different structures that are useful to us. Each application has made a decision about what objects are relevant to the task that it's being used for, and what properties those objects have, and how those objects should be visualized so that it's easy to understand them at a glance. And those applications also provide appropriate interactions for manipulating that data in various ways, for modifying particular properties of a particular object. And they decide how groups of objects should be gathered into collections and how you should be able to manipulate the collections of objects. And they also have ways of linking different objects so that you can navigate from one to the other. So this is why we have these specialized applications. And so I'm going to be talking about these applications and how to make them better. I'm going to be looking at this both in the context of general structured data, things like photos and email and videos and so forth. And also I'll be looking at online discussion platforms where I think there's a lot of exciting opportunities to enrich the discussion with richer text. And the general theme will be that the computer is playing a relatively dumb role. It is storing the information, and it is up to the human being to bring meaning to that information. So I'm going to start by talking about structured data applications. And here, the problem that we face is that there are so many different tasks that people need to perform that most of those tasks don't have perfect applications, right? There are relatively few programmers, and you can't assign a programmer to each human being to make the perfect application for that human being. And so we instead get these sort of general purpose applications, right? The person who's working in a corporation gets the same mail program as somebody who is an entertainer or working from home, who has very different communication needs. A professional artist may be working with the same photo management tool as a hobbyist. Even worse, there are many times where in order to accomplish a task, it feels like you have to use many different applications and juggle information, moving it from one application to the other, and losing a lot of information in the cracks between those applications. And so you've got these end users who have a lot of expertise on a task, and often if you talk to them, they can really do a pretty good job describing the limitations of their applications and how they work around those limitations in order to get their work done. And they have great ideas about what application would make it easy for them to do their work. But since they can't program, they can't make these perfect applications. But then you sit back and think, is that really true? So one of the most dominant advances in computing was the invention of the spreadsheet. The spreadsheet is really a kind of universal application to let anybody manage data, right? You can put any data that you want into the rows and columns of that spreadsheet under whatever arrangement you like, and you can use spreadsheet functions to compute over that data. So, there's actually an old piece of work showing that the majority of spreadsheets don't actually have numbers in them. They're being used as tables to arrange other kinds of structured information. And so they work really well for this, but their limitation is their layout, right? The only way you can look at that information is in the table of the spreadsheet. And you don't get the kind of specialized at-a-glance layouts and the specialized interactions that are provided by customized applications. And so our goal is to somehow empower end users to not only put their data into a spreadsheet, but also to create the look and feel of the applications they need, all of these customized visualizations and presentations and interactions with that data. Now, spreadsheets are not entirely helpless at this. Many of you who have used spreadsheets have probably at some point created a chart of some sort. So you selected some columns of the spreadsheet and you picked some kind of chart that you wanted to use to show, and the spreadsheet generated an appropriate visualization of the information in the columns that you selected. And we thought about this and decided to sort of generalize that idea and say, well, you shouldn't have to stop at charts. You can think about all of the different kinds of information management components that show up in an application, lists, templates for presenting information in a nicely laid out fashion, buttons and drop-down menus. And these are all things that you can envision attaching to the columns of a spreadsheet the same way as you attach a chart to the columns of a spreadsheet right now. And so my group has done a series of projects to explore that idea, where you think broadly about the kinds of components that people want in their applications for interacting with data. And you let people independently choose these components and arrange them and attach them to some kind of underlying spreadsheet-like data model. And that lets them create their own applications. So the first of these projects was in the early 2000s. It was called Haystack, and it let users choose particular components. In the center, we have a collection component. This is a user-constructed email application. So an email application is about managing a collection of emails. There is a component for looking at a collection. Then there is a component for looking at an individual email as a row of different properties, like who it's from and what is its date. And there are checkboxes for setting certain properties of the row and drop-down menus for manipulating and interacting with that information. Now, after the Haystack project was over, we looked around and we realized that there was this thing getting kind of popular called the web. And we decided to migrate our research off of desktop applications and start thinking about the web. And on the web, we found that there was this very interesting approach of HTML as a very simple language for authoring documents. And within HTML, you could specify using tags various components of a document, like a paragraph or a title or an image or a link to another document. And this was really powerful because you could write, essentially you would author a document, but it would have all of this rich formatting and even a little bit of interaction. So anybody could create these documents. And actually, most people never even learned HTML. When they wanted to create a document, they would just find a document that looked kind of like the one they wanted to create, and they would download it and copy it, and then they would modify it a little bit to look like what they wanted. But the limitation of this web was that regular people were really only creating static content, just documents that you could read. Meanwhile, professional organizations, companies, were creating these really rich interactive websites, which had that had functionality for searching and sorting and presenting information in templates and filtering that information according to all sorts of interesting properties. And of course, they did this by leveraging the structure of the data that they were presenting. But this required programming. People built these web servers that talked to databases and rendered the information into web pages. And so we wanted to bridge this gap. We noticed that, in fact, if you looked out on the web, there was this really common pattern of these websites that had collections of structured objects, and they would show them to you in particularly formatted templates, and they would let you filter them according to particular properties and search and sort them. And so, this is a recipe website that has that pattern. Here we have an early version of eBay, which has that pattern. Individual products, which you could sort and filter in various ways. Photo sharing websites like Flickr, review websites, housing websites, museums, they all tended to have this same structure. LinkedIn for contacts, now you have a collection of people, but you're still templating them and sorting them and searching and filtering. So we built a tool called Exhibit, which basically tries to empower regular authors to create these kinds of websites. We identified these key primitives of a data interaction web page, these templates that show how to display a single item, and the views that can show you lists or maps of collections of items. And these are a lot like the charts of a spreadsheet, where you specify which properties of the data do you want to present or connect to in the view. And also filters for filtering that information based on its structure. And so once we identified these key data interaction components, we actually just added them to the HTML vocabulary. So instead of saying, put a paragraph here, you would say, put a filter here. And our exhibit framework would take care of reading that instruction and actually putting that filter into the right place in the HTML document, connected to the data the same way that a chart is connected to data in a spreadsheet. So Exhibit was just a little JavaScript library that loaded data from your spreadsheet and gave you this interactive website using only 2 files. There was nothing that the user had to configure or program. They just wrote an HTML document with a little bit of extra information, and it all ran in the user's browser. Now, this may be a little bit abstract because, and I'll give you more details of that when I talk about the next project, but I did want to share with you briefly just an example of Exhibit. So this is the kind of information visualization that you could create with Exhibit. So here the author of the document said, this is a presentation about US presidents. The author of the document said, put a timeline on the top, put a map on the bottom, and put filters on the left that let you filter on the religion of that president, of the presidents, or on what presidential party they came from. And the author also specified certain ways that particular presidents should be displayed if you wanted to get more details about them. And all of this was done simply by authoring HTML. So this, for those of you who know HTML, is a tag that you put into the document to say, I want to make a map. And all you have to specify is which column of the data has the latitudes and longitudes for the items that you're putting on the map, and which column of the data has links to the images that you want to show in the map. And you connect this all to a data file, which I'm showing you here. And that's enough to let the Exhibit framework generate this rich interaction. So now I'll return to the slides. All right. Tell me if there's, let me know if there's any problems with this screen switching. But now that I'm back on the slides, the outcome of the exhibit framework was that it actually got somewhat widely adopted for a research project. There are about 800 different websites that used exhibit. There was one selling musical instruments. There was one showing DNA sequences. Another put their PhD thesis data online through an exhibit. Government websites used it to present various data collections. Non-governmental organizations used it to show the status of legal cases. Newspapers used it in their reporting. Libraries used it to manage their collections. It was just sufficiently easy that we saw all kinds of uptake of this simple tool for displaying all sorts of information and providing rich interactions with it without ever having to write a line of code. There was even an Urdu to English dictionary created, which is a pretty bizarre way to use our tool, but it was easy and effective. So that was the exhibit framework. I now want to talk to you about our latest project in this space, which is called Mavo. And Mavo is a project that really tries to go beyond just presenting HTML, and it wants to empower people to actually create rich interactive applications that let people not only look at, but also manipulate the information that they are that they're looking at. Sorry, I need to switch screens again. Right here. So for Mavo, we focused on what are called CRUD applications. These are the majority of applications where really you just need to collect information, look at it, edit it, and sometimes remove it. And so many tools like an address book or a photo album or a recipe collection, these are sorts of applications where you're just creating and doing simple management tasks over data. But if you wanted to do this on the web, you couldn't work just with HTML and CSS. You would have to learn all of these other programming languages and functionalities in order to create the application. And this is, of course, exhausting. And in fact, even if you think about a simple tool like a to-do list, there's a website that lets all of the different programming frameworks show how they would create a to-do list using their programming framework. And they report that this in general takes hundreds of lines of code. And that makes it something that only programmers can do. And we wanted to make this kind of creation of applications accessible to non-programmers. And so we developed a tool called Mavo that lets you create a simple to-do list like this without writing any lines of code at all. You basically just make a picture of the application that you want, and you then start, and Mavo takes care of turning it into a working application where you can add tasks, check them off, delete them, and so forth. So, as I said, we're continuing on this theme of just looking at HTML as an authoring language. And this is the HTML that would be used to create a picture of your application, right? It has a header saying my tasks, it has some text saying how many you've done, and then it has a list of individual task items. Now, if you make this HTML and add some CSS for styling, you get something that looks like a to-do list, but it doesn't do anything, it's static. So what Mavo does is it extends the HTML vocabulary with some useful terminology for describing which parts of your HTML are actually data that can be used and that can be edited and manipulated. So here we're telling our Mavo framework that the items in the list are actually tasks, and that each of those tasks has a done property that's managed by a checkbox and a title that is text and editable. Up above, we explain that we want to display in the textual summary the count of how many of the tasks have their done property set in the checkbox and how many tasks there are in total. So Mavo comes with a lot of, a small amount of syntax for describing what you want in an application. You use the data store attribute to say whether you want to store the data locally or maybe on the web, on Dropbox or on GitHub. You specify which parts of the web page are actually data that have property names associated with them. So these are sort of the columns of your spreadsheet. And as soon as you specify that something is data, it becomes something that you can edit right there in the web page. You can also associate data with various kinds of form elements like sliders and drop-down menus, which provide other convenient ways to edit that data. You can specify that some of the properties are actually images, and Mavo will take care of actually displaying those images for you. And it will let you edit all of the different types of data using appropriate widgets that are suited to the specified data type. You can also create multiple collections of items. And if you specify that a collection should have multiple items, then Mavo will automatically provide the functionality for adding and removing things from the collection. And finally, you can write expressions that take all of the data that you've written into the page and provide spreadsheet calculations over it. So you can add things or concatenate things. But instead of referencing the grid cells, you refer to the properties that you've named in your data. So here, for example, we have a simple expression saying take the value of the strength property and divide it by 100. So the strength property is managed by this slider, and it has a range from 1 to 100. And as you can see that as I move the slider, the calculation is just updating itself the same way as a spreadsheet would. Here's another example of that, where I can drag a slider around, and as I do, it simply directly updates properties that are used in expressions that describe other parts of the application. You can also use these expressions to aggregate information. So if I edit this collection and say remove certain items, that immediately updates the expressions that have been calculated involving the number of the cats and how many of them are old and so on and so forth. So essentially, you've got this simple language of things that you add to your HTML that describe what is the data and what calculations do you want to perform on it. And using this simple language, you can write HTML documents that give you very rich presentations and interactions. So here we have something for choosing colors for designers. Here we have one for manipulating icons. Sorry, my slides are getting a little out. Here we have a mortgage calculator where you type in some numbers and it tells you what your monthly payment is going to be. So there are many of these tools. And I now wanted to show you briefly how we evaluate in HCI. So after you build a system, how do you decide if it's working? So we designed a study to try to understand whether it was really true that people who don't know programming are able to learn to use a tool like Mavo and use it to create rich applications. So we recruited a bunch of participants over the web, and they were all people who described themselves as understanding HTML, but most of them were just beginner programmers. Some of them had a little bit of experience. And when we invited them to come to our study, we didn't tell them anything about Mavo, but we asked them to use their HTML knowledge to create a mock-up, a picture of what they would like in a contact manager application. So a tool for keeping track of all of the people that you need to keep to stay in touch with. And 8 of these subjects did actually bring a contact manager mockup. We then sat them down and we gave them a 45-minute tutorial on the Mavo syntax, the things that I just showed you very rapidly. And then we gave them a series of tasks where we told them to build a particular web application. And we broke out the steps into tasks of increasing difficulty. First, we just wanted them to add annotations that would make the content itself editable. Then we asked them to add some basic expressions that would calculate things for this content that they were showing. And then we asked them to do more complicated expressions that would aggregate information from many different objects on the page. After we had them do this series of tasks that we defined, we then asked the people who had brought their contact manager mockups to turn those contact managers into fully functional applications where they could add and remove contacts and just manipulate that collection the way that they wanted to. So we gave them 2 different tasks that we wanted them to do. The first was to make a web page for keeping track of all of the restaurants that you'd been to and all of the food that you ate there. And the second was to make to build a decision-making app where you could collect the pros and cons for a particular decision, and it would tell you whether the pros outweigh the cons or whether the cons outweigh the pros. And so the first steps here were just to record the information, what were the restaurants, and then the next step were to compute some basic expressions like what were the values of your ratings on the restaurants, and then to compute some more complex expressions like what was the average of the ratings of all the different kinds of food that you had at this restaurant. And so each of these used a different part of the Mavo syntax. And we wanted to see which of these parts people would be able to use quickly and which parts they would find more difficult. So this is the decision-making application. You start filling in your different choices, your different options, and what are the positive and negative aspects of that decision. And it tells you whether you should take that decision or reject it. Similarly, this is the food application where you can fill in a description of a restaurant and its screen, and you can then record when did you visit the restaurant and what did you eat and how did you rate it and so forth. So we showed people these applications and we asked them how long they thought it would take to build them. And the responses range from a few hours to months because I would have to learn how to program. But it turned out that all of our subjects were able to complete the tasks that we gave them. And all of them succeeded in the basic functionality of making the data editable. And almost all of them succeeded in being able to author spreadsheet-like expressions for doing computations over the data right in the web page. And after having completed that work, they all suddenly said, oh yes, this was very easy. It didn't take months, it took us a few minutes. We carefully analyzed what was easy and what was hard, right? They had more difficulty when the expressions that needed to be evaluated had to be part of more complex strings, for example. They had an easy time just putting expressions into the HTML itself, not so much when the expressions had to be combined with other text. They had a lot of trouble with conditionals, which is not surprising because this is also complicated for programmers. People said, you know, just seeing these if statements, it frightened them because it made them think about programming. Then when we ran the freestyle study and asked people to create their contact managers, they were able to do so. So these are 4 of those contact managers that people brought in. You see how different they look, what different ideas different people have about the way they want to present and interact with their information. And the result is that all 7 of the people who brought in these contact managers were able to convert their own HTML into fully functional applications in just a few minutes even though they created their mockups without knowing anything about our application design language. And so this suggests that Mavo really can work to turn real web designs into functional web applications without any programming at all. Some people liked it so much that they went back and built their own applications. We're starting to see broader and broader uptake of this in the wild as people are building actual professional websites using Mavo. The feedback we got was that this was incredibly simple. It was really just like authoring a document in HTML. They thought it would be hard, but it turned out not to be. They loved how easy it was to learn. You just had to name properties the same way as you gave classes and identifiers to things in an HTML document. They also felt that this was incredibly useful. It really solved a problem that they had, and it was something that they wanted to have in their own work. All right, that's the end of the story for Mavo. And so now I'm going to return to the slides and talk to you about the summary of all of this, and then move on to talking about structured data. All right, we still doing okay with the slides? People see what I'm showing?
Yes, David.
Great. So this first half of the talk was a story of how non-programmers can create applications. All we had to do was enrich the HTML document authoring language with additional markup that described data and the interactions that you wanted to have with that data. And we've done user studies that have shown that with a little bit of tutorial on these HTML language extensions, non-programmers can actually create fully functional applications. And we've got a lot of additional research ongoing on this work to think about multi-user applications and access control and interaction with the data on remote websites. But I think this line of work has been going very successfully. So now I want to switch gears. I do want to emphasize one thing that I think is very interesting about this work, which is that we've been designing languages, not systems. So I think nowadays you see a lot of platforms out there that offer no-code programming or low-code programming environments, where if you go to that platform and use their components, they will let you build an application and host it on their platform. But we think that having a language is much more powerful because the applications that you build with Mavo can live anywhere on the web. And anybody who sees a Mavo application that they like, they can just download that application and make a copy of it, just like people used to copy web pages, and modify it into a different application without having any formal education about how it works. So we think that this is very powerful and democratic. So now I want to switch for the remainder of the talk to the idea of structuring discussions. So online discussions today are everywhere, but they're all the same. They're these streams of posts with comments and replies. You can look everywhere, on Facebook, on news sites, on YouTube, and everywhere you look, you get exactly the same sort of linear sequence of posts and replies. And you know, the number of posts can get insanely large, to the hundreds or the thousands, or there are comment sites on YouTube that have 500,000, sorry, there are videos on YouTube that have over 500,000 comments on them. Now, how many people do you think actually read those comments? Probably none. There's just too much there. And it's very poorly organized, right? All you get to do is, you know, like some comments or reply to some comments or follow some users. But there is really very little rich structure. And as a result, you get information overload. There's too much, and so you don't look at anything. And so I think in general, you get these sort of write-only comment streams where lots of people are contributing comments and nobody's reading anything. And indeed, we've seen this phenomenon over the past decade of various websites just giving up on online discussion. They've decided to turn off their comments because they're not useful for anything. So in my group, we've been spending the past decade thinking about how we might add structure to discussions in order to make those discussions more useful. And today I'm going to talk to you about two approaches we've taken. One is summarization, and another is, which is to try to find a way to take a giant discussion and squeeze it down into something small and tractable that somebody can actually read. And the other is annotation, which is to try to organize discussion around a particular piece of content being discussed. So for summarization, I want to tell you about Wickham, which is a project that we did about 3-4 years ago. The goal of Wickham is to bring understanding to large discussions. Filtering may let you reduce the volume, but it doesn't let you understand the entire discussion. And you may lose out on important perspectives or key ideas. So we really wanted to think instead about a summary. Now, a summary is a nice idea, but who's going to do the summarization work on a discussion that has 500,000 posts in it? I mean, lots of people are willing to write one post, but who's going to summarize 500,000? Nobody. So what we needed to think about was whether it might be possible to kind of divide up the summary task. So if 500,000 people wrote posts, that means that you have 500,000 people who might be able to do some summarization work if you could kind of get them organized. So Wickham is a tool that tries to create some of that organization. You can think of it as kind of a wiki for summarizing things. You start with a long discussion, and the way it works is that anybody who's looking at any part of that long discussion and has read a little sequence of posts in that discussion can take that series of posts that they read and replace that series of posts with a summary of that series of posts. And that replacement of that series of posts with a summary has just made the entire discussion a little bit shorter. The summary replaces those posts in the discussion. But you can expand that summary if you want to in order to reveal the original content. Now, writing one summary of a few posts only makes the discussion a little bit shorter. But you can have more people come along and write more summaries of more parts of the posts. And as more and more of the content of the discussion gets summarized, it keeps getting shorter and shorter. And eventually you start seeing people summarizing not original parts of the conversation, but you see them actually starting to summarize summaries into even smaller summaries. And in a sense, if you think about the outlines that we often create for articles before we write them, right? Usually you think of creating an outline from the top down. You start with the big picture and you break it down into pieces. Wickham is kind of doing the reverse, where you start with the entire article and you build the outline from the small pieces, working your way up to the top level. So when you finish, you've taken this this discussion, this entire discussion, and you shrink it down smaller and smaller into summaries of the entire discussion. So because the summary is created through this series of summarizations, you end up with what we call a summary tree. You have a top-level summary, which summarized some lower-level content. And if you want to, you can expand that top-level summary in order to get additional details. If you want even more detail, you can expand lower-level summaries and just keep on expanding the summaries until you end up with the individual posts for as much detail as you want. So, sorry, I'm racing a little bit because I want to watch the time. But the way Wickham works is, this is the Wickham user interface, which you can play with yourselves at wickham.org, is you have this view of the entire discussion with a tree on the left showing the current state of summarization. And you can select some of the comments and read them, and then open up a modal dialogue for writing a summary of the comments that you just read. You can also include citations and quotes from the comments, because that's very useful in writing summaries. And what you end up with is something that sort of combines the features of a wiki and a forum. It's something that everybody is writing together, but it is also something which has all of the kind of back and forth of an online discussion platform. So here too, we needed to evaluate this tool. And so we started with some long discussions, and we selected a certain number of comments from them to create a smaller discussion of about 8,000 words, which would take 40 minutes to read in its entirety. And we decided to study how Wickham could be used to summarize this. And we wanted to study both the process of summarization, how did people use Wickham to create the summary, and also the product of the summarization. Was it a good summary that people created through this collaborative summarization process? So we again recruited a number of participants, we brought them in, and we had each person come in and summarize these discussions. And in order to do a comparison, we gave them two conditions. In one situation, they were told to summarize using Wickham. In the other condition, we simply put the entire discussion into a Google Doc, an editable document, and told them to write the summary by editing the discussion in the Google Doc itself. And we had groups of people creating each of these summaries. So here's what the discussion looked like at its starting point in Wickham. All of the comments are blue because they haven't been summarized yet. Here is what the discussion looked like in its starting point in a Google Doc. After people did some summarization work in Wickham, you still had this nicely structured tree of discussion, but some of the content is now orange, representing the fact that it has been summarized. Meanwhile, the Google Doc just started to get more and more complicated as people colored things differently and crossed stuff out in order to try and keep track of the summarization process. So when we compared the efforts to summarize in the Google Doc versus summarization in Wickham, we found that people using Wickham just completed the summarization task quite quickly. Meanwhile, it took a lot longer when people were using the Google Doc, and in fact, none of them actually finished the entire summarization task in the time that we gave them. We also found that people spent a lot more time in the Google Doc condition just trying to figure out what was the state of the summarization, what still needed to be summarized, and how should it all be organized. So this showed that Wickham really provided a lot of the structure that would help to do this summarization process. People using Wickham would say things like, well, looking at the whole discussion, it seemed really hard to summarize. But with the structure provided by Wickham, where I could just summarize a small piece of the discussion, that suddenly made it feel tractable. I knew what I had to do, and I could just work on that small piece. So this is just another example of how providing the right structure in an application makes the work much easier. People also really like the ability to cite and quote posts so that you could sort of look at a summary and be able to ask, well, is this a good summary? Where did the summary come from? Does it accurately summarize the underlying content? We did a second step to evaluate the product of the summarization. Was the summary that was created something that conveyed the main sense of the discussion? And the way that we tested this was that before any of the summarization happened, we went through the discussion and identified 6 topics that you could imagine being relevant to the discussion. And 6 of them were actually present and 6 of them were not. We then recruited people from campus and we brought them in and asked them to spend 40 minutes exploring the summary. And again, some of them were given a chance to explore a summary in Wickham, and then they were also given a chance to explore a summary of a different discussion in a Google Doc, and a third summary they explored in its raw, unsummarized form. And for each of these conditions, the 2 different summary conditions and the unsummarized condition, we asked the users which of the discussion points they remembered encountering in the discussion. And so what we found was that compared to the Google Doc summary or to the document with no summary, people did a better job of understanding which topics were in the discussion and which topics were not in the discussion. They understand, and on both sides, they accurately remembered, they better remembered with Wickham the topics that were present in the discussion, and they did a better job of remembering with Wickham that certain topics did not appear in the discussion at all. So this provides evidence that Wickham was being used to create good summaries. So Wickham was both fast for creating the summaries and creating summaries of high quality. In this process, we also learned a lot about how people like to make use of the summaries. Some people like to just work from beginning to end, while others like to drill into specific parts of the discussion. And the Wickham interface with its expandable components really supported a lot of these different strategies for exploring the discussion. And people, again, reported that they liked this structure, that they could navigate a really richly structured summary of the entire discussion compared to the Google Doc where everything was very, very messy. So again, we're getting quotes directly from our users about how having additional rich structure really made navigation more effective. All right, so turning to the very last tool I wanted to tell you about. This is a tool that is supporting, that moves online discussion to the margins. And this is a tool that we developed for use in classrooms. Some of you have probably had this experience of using an online discussion forum where you can ask questions about the material in your class. And if you're lucky, other students will answer those questions, or maybe if you're really lucky, those questions have been answered before you even get to the forum, and you can find those answers while you're reading your course materials and get your questions answered. And in fact, there's a lot of research in the education community that shows that talking about your learning material in this way actually helps people learn. There have been these careful studies done that show if you're just reading, you don't learn very well. If you do exercises or take notes, that improves your learning. But really the best way to learn material is to talk about it and explain it to other people. So there's a really good role for discussion forums in a classroom, but the kinds of discussion forums that people typically use are very limited because they don't have context. If you're reading a textbook or some course notes and you have a question, you have to stop reading. You have to go over to this discussion platform. You have to ask your question, or you have to hunt through this entire discussion platform to see if maybe somebody has already made a post that might provide an answer to your question. And once you do decide to ask your question, you have to explain all about where you were in the reading and what your question is about. And it may be so much work to ask your question that you don't bother and you just decide to stay confused. The faculty also don't get much out of this. They would have to read every single post in the discussion forum in order to understand what students are confused about and what they are understanding. So our idea was to take this discussion forum and just put it right into the document where you're reading. So NB is a plain old threaded discussion forum where the faculty member just uploads their content and the students discuss that content right in the margins. So here's a picture of NB. You can see the course content on the left, and you can see that there are little boxes around some of the course content. Each of these boxes corresponds to a comment or a discussion that's happening in the sidebar on the right. And if you click on any one of the boxes, you are immediately navigated to the relevant discussion, which you can read. And so you can see here that somebody has clicked on this 3 angstrom indication in the text, and they asked, how did we get 3 from 1? And I want to draw your attention to this. Can you imagine going to a regular discussion forum and typing, how did we get 3 from 1? It wouldn't make any sense because there isn't any context. But the fact that you can actually put a circle or put a box around the text makes it completely clear what you're asking when you say, how did we get 3 from 1? So already you can see that having the discussion in context is adding a lot of value. And so this is another example of just adding a little bit of structure to a discussion. So here the structure is location, right? So instead of just having all of the comments in chronological order, the comment is located right next to the appropriate piece of content. And of course, somebody who sees one of those questions while they're reading can just hit reply, and a whole interesting discussion can happen around that question. and anybody else who runs into that piece of content can see that discussion and benefit from it. So the results of this are that you can have the discussion as you're reading without leaving the document, and you can stay in the flow of your reading. And instead of having to navigate through all of the discussion forum, you can see the comments that are relevant to what you are reading now. And you can also see the questions that other people have. And so as you're reading this content, you can say, aha, somebody is confused about this content and I've just read it, so I'm perfectly set up to answer that question that somebody has. The context is clear. Another really great benefit of this is that the locations of the comment can tell the faculty member where are the students asking questions, where are they confused, and where do they have no problems. So this is not a new idea, this idea of annotating a text. This is an old Jewish text called the Babylonian Talmud, and it was written about 2,000 years ago. And 2,000 years ago, this blue part was the only part of this content that existed. But a few hundred years later, people started writing annotations on the original content. And a few hundred years after that, they actually started annotating the annotations. And a few hundred years after that, they put annotations on the annotations on the annotations. Okay, and so this is sort of 2,000 years of annotations slowly piling up on a single primary source document. In modern texts as well, you sometimes find annotations. This is a really wonderful textbook called Concrete Mathematics, where the professor asked the student to write comments in the margins, and then they publish those comments as part of the text. But none of this was interactive. And so NB provides the opportunity to do all of this in real time as you're reading. Now here too, we ran an assessment. We've put NB out in the world. And at this point, about 1,000 classes have used it with 60,000 students to produce over 2 million comments. These statistics are a little bit old, and the usage keeps growing. It's in every imaginable course topic, and the tool is frequently reused to teach the same course over and over again, which shows that it's working, that the faculty are finding it valuable, and that the students are benefiting from it. Here's a list of various courses all over the world in many different universities that have been taught using NB. And I've highlighted one that was one of the earliest that was taught at MIT by a visiting professor. And that's one that we studied in more detail. We analyzed the annotations, the 14,000 annotations that were written on this course, to understand how long the discussions were and what kinds of discussions there were. So for example, we found that about a quarter of the discussions were commentaries suggesting different ways of explaining something. A third of the comments were questions being asked by the students. 20% of the comments were answers to those questions, and the vast majority of those answers were from other students, which shows a really great scaling, right? It's very difficult for a faculty member in a large class to be able to answer all the questions that students ask. So if you've got students answering other students, that makes for much more scalability. You get faster answers. We also found that usually students answered questions in the thread that they were asked, but that thanks to the location, the localization of the discussion, there would actually be crosstalk where students in one discussion thread in a particular place in the document would refer to other discussions in the same place in the document in other threads. What did users say about this platform? Well, the students felt that it was giving them tremendous access to collective intelligence of the class, that everybody had different kinds of expertise, and the In the Margins discussion platform really brought everybody's shared intelligence together to answer questions. They also found it very reassuring to see that they were not the only confused people, and that everybody was asking questions and answering them. The faculty in general were very satisfied with this tool. They found that the comments had very high quality, and the vast majority of faculty chose to reuse the tool because it was providing value in their classroom. And this is despite the fact that NB was a very clunky research tool. We had not expected it to be adopted so widely, and we did not do a good job building something robust. The faculty loved the fact that they got to know their students through these discussions. They could see what was exciting the students and what was confusing them. They felt that the online discussions were of much higher quality than the ones that they had been able to generate in the classroom or in typical discussion forums. And they felt that they could use the discussions to tune their lectures to students' needs. They often modified their lectures. Instead of just presenting, a lot of their lectures turned into times to discuss things that came up in the NB discussion that happened before the class. And it was obvious that the vast majority of students were actually reading before the class happened because they could get this feedback while they were reading. Now, you might think that a lot of this could happen with any old discussion platform, but we got evidence that the situating of the discussion in the margins really made a difference. I'll in particular draw your attention to this third quote, where they saw that a particular part of the text was just dripping with questions and confusion. And this led the faculty to devote their entire class to that one section of the text where the students were confused. And in a typical discussion forum, it's much harder to get this overview of what parts of the content are confusing the students and what parts do they understand. We also saw in the kind of comments that people were benefiting from this context sensitivity and could ask questions like, how do you get 3 from 1? That just wouldn't make sense without the context of the discussion. We also logged the interactions that students were having. So here we have a chart that you should basically think of as that the x-axis represents time as the students begin their reading and time continues until they end their reading. And what we did was we tried to identify when are students writing and answering comments. And we created this sort of bar chart that shows some of the comments happened at the very beginning of their reading activity, and some of the comments happened at the very end of the reading activity. But overall, you can see that the comments are just evenly spread out. They were commenting all the time while they were reading the document, which shows that commenting became an integral part of the reading experience. And we think that this is because you could see the comments while you were reading, and this would stimulate you to actually participate in the discussion while you were reading, and it would create a critical mass of student engagement in these comments. So in summary, we found that annotation in discussion, for discussion really can work, and that it generated substantial amounts of student-student teaching and a lot of guidance to faculty about where the students are being confused. And again, just like with Wickham, just like with Mavo, NB isn't doing anything intelligent. It's just holding the discussions that the humans are contributing and organizing those discussions as the students and faculty want. So the key for the tool is to provide the information in the right time and place, this structure according to location. And all of the intelligence comes from the human beings. So just to reflect on these two tools, Wickham and NB, these are both tools which are sort of richer discussion platforms that are both special cases of a general kind of hypertext where you link different pieces of content together. And hypertext was a really exciting idea in the 1960s that we don't see much of anymore. The one exception is Wikipedia with all of its linking together of articles, but it's not really widely used on the web. And we think that this is because hypertext is just too general, and you tend to get lost navigating through all of these linked content. Both of our tools provide more structure than that. Annotation keeps you centered on the content, and summarization has this tree of broader and more detailed summaries. And we think that there are other opportunities to think about richer structure that's not as powerful as general hypertext, but is more navigable. And we're exploring various research projects in this direction. So I've come to the end of my talk. The conclusion I hope you've come away with is that people can do really interesting things with information if you give them the right tools, right? If they have the wrong tools, then they have to warp their work to fit the tools. And we want to instead modify the tools to fit the work that people want to do. You can't just expect the tool to figure out the right information if you don't give people the right interfaces to record the information that is important for their task. And we think there are many opportunities to make things better. And I've shown you a few that I hope you think are exciting. You can try out most of the tools that I've told you about, and you can find links to them here. These tools are all actually open source projects, and we welcome contributors and participation in the work. And I'll end there. Thank you very much.
Thank you so much, Dr. Kaga, for that very interesting and enlightening session. We're going to open up the floor now to some questions from the audience. I'll be reading out the questions for you. So we have a question here that says, how do you correct, control, or arrest fake propagation of information in the AI and data science flow of stream?
Sorry, so could you just repeat the question again?
It says, how do you correct, control, or arrest the fake propagation of information in the AI and data science flow of stream?
Okay, fake information. Yes, that is a really interesting question. Actually, we have a whole additional research project that we're working on right now, thinking about the propagation of misinformation, which is a really big problem nowadays. And again, our approach to this is to think about adding structure. So if you look at standard discussion platforms, again, all you see are posts and replies. So somebody can post something and somebody might reply saying, this is incorrect. But unfortunately, somebody who's reading the original post might not even get to that reply. So we've been working on a tool called TrustNet, where instead of just saying that in a reply, we actually add structure where you can, where a participant could actually add a marker to a post saying this is fake information and you shouldn't look at it. And we combine that with another piece of structure, which is that we allow every user of the platform to say who else in the platform they trust. And so once you have these markers of trust and what different people are saying is true, you can actually use that to filter the information that you're looking at so that you can get a feed of information where you only see information that has been asserted to be true by people that you trust. And so this provides a very strong protection from the misinformation that bad actors are trying to share. And it doesn't require, again, it doesn't require any artificial intelligence at all. Instead, we're just providing an interface with this richer structure of trust and provenance that lets people who have a good understanding of what's true and what's not to be able to provide that understanding into the computer system for others.
Thank you for that. Someone else was asking if there are any technologies available for analyzing and visualizing voice data.
Voice data. Well, so there's actually a lot of work right now, not just for analyzing and visualizing voice data, but and this is very relevant to the Institute. A lot of the work on human-computer interaction right now is thinking about how to build good interfaces for people who need to work with and train machine learning platforms. So if you're doing speech recognition, for example, you may need to do a lot of work examining training data, annotating it in the right way for use by a machine learning model. And so this is generally referred to as well, there's different names, but for example, there's human in the loop artificial intelligence, which is very heavily focused on the development of such interfaces.
Okay, I think that brings in our next question quite well, which is asking, can AI or ML help us build better user experiences without human interaction? Or is that a field that still requires human intervention for thinking out processes?
That's a really interesting question. So I think that the hardest part of our work is design, right? So what should the application look like? What are the important pieces? Where should they go? How should it be laid out? And I think we're just barely beginning to think about doing that using artificial intelligence. There was a very beautiful project called Supple that was developed by Christoph Gajos, who's now a professor at Harvard. And Supple was a platform that actually reconfigured user interfaces based on the needs of the user. And it was actually specifically designed to deal with various kinds of accessibility issues. So some users might have vision problems, and other users might have motor, and so people with vision problems might need very large text, and so you have less room for your application. And then there might be people with motor control problems who have trouble pushing buttons, and so you would need very large controls. And so his Supple platform actually let you describe kind of what were the constraints of how much space did you have, and what was the user able to do. And we would, and Supple would then do some very sophisticated computations to sort of figure out an optimal design of a user interface for that particular user. So I think that was really beautiful work, and it points in the direction that we could hopefully someday make use of sophisticated AI for this, but it's still very much in the early phases.
Okay, thank you. A few people are asking if Mavo is also a JavaScript library.
Yeah.
You already answered that it's an open source. And then does any backend server require, is there any backend server required for Mavo?
Right. No, so Mavo is, again, just a JavaScript library. There is no server. You just put a link to the library in your web page and you're done. You then write the whole application in HTML and it just works. Now, you can, if you want, specify a server as the data storage location. So you can say that you want the data to be stored in Dropbox or on GitHub or even in Firebase. And so Mavo takes care of accessing that server for you. So you don't need to understand anything about it, but you can make use of it if you want your data to be accessible anywhere. You can also build your application so that it just keeps the data in the browser. And that makes it entirely private. But it means that you can only access the data in that browser and you won't be able to access it from anywhere else.
Okay, thank you so much for answering all those questions. That was our last question. I'm going to now reintroduce Dr. Larry to just close off for us. Thank you.
Well, David and Louisa, thank you for that and for moderating the question session. David, thank you so much for your talk today. I was inspirational, really, in a number of ways that I'd like to touch on about why this kind of work is so relevant to Geo Institute and our aspirations. First of all, Geo Institute takes a very broad view of AI and data science. I mean, to build an end-to-end AI or data science application requires a lot of work, not just in machine learning or knowledge representation, but also in databases on one end and in human-computer interaction on the other end and in design. And so we're, to educate students to really be able to manage the entire pipeline of stuff that has to happen to build a real application in the world that will do something useful for people requires really mastery of all of these technologies. And we're grateful to you today for outlining some of what's going on there. And also this provides a way to actually broaden the education of our students to include things like design, not just probability and statistics or databases, but design, human-computer interaction, all the things that are relevant, again, to shaping a computer scientist and AI and machine learning person and data science person who can really contribute broadly to the field. I want to say two other things, and I'll say them briefly because we're a little bit over time. First of all, one of the things that I really loved about your talk was the way that you unpacked what looks like very simple human needs or very simple human behaviors regarding information access and use that turn out to be quite subtle and quite complicated upon reflection, and that require really a lot of work to dig in and to see ultimately how to express them in a way that will be useful for people. And that's actually something that AI on the one hand and HC on the other hand both share, the need to be able to look at human intelligent activity and see the complexity of it in things that seem so obvious and sensible to us every day. I mean, some of the challenges that we find in interfaces, we don't even notice them. We build our workarounds without even thinking about it. We just build the workaround and we use a crappy system without, and we just use it forever because we've had that capability. Finally, I want to point to the power of abstraction, which I think your talk really reflected very well. I mean, it's often said that computer science is the study of algorithms, and I think that's certainly true. But the other important part of the power of computer science is the power of abstraction, of building the right abstraction to look at a problem that allows you to express it in a way that the results will be applicable very broadly, not just to a particular application that you're building, but to a whole genre of applications that actually meet that pattern and fulfill similar needs in different domains. So I think those were my three big takeaways from your talk, and I appreciate it very much. Thank you again for sharing your wisdom and research with Geo Institute community today, and look forward to further interactions in the future. Stay safe, everybody. And finally, I want to say to everybody, I hope that you and your families are well. It's been a very trying year and more for all of us, and be safe.